Welcome to the Texas Instruments Australia webinar series. This webinar will be presented to you by Mr. Brian Lannon and Mr. Russell Brown. They will be looking at examination readiness relating to the Further Mathematics course. This will include the use of the TI-Nspire CAS to answer examination type questions from the Further Mathematics course. Sorry, just gone a little bit too quickly there. Brian and Russell will be covering many topic areas showing the use of applications and such as the use of notes on the CAS. The webinar is being recorded and will be available on demand on the Texas Instruments Australia website. During the webinar, if you have any questions, please move your cursor to the top of your desktop. Select Chat and pick All Participants. We will endeavour to answer all questions as quickly as possible. If you have problems hearing the webinar via your computer, check the sound option under the Communicate menu. Also ensure the sound is not muted. You can also listen to the webinar via telephone. Details were given at the start and can be found when you log in and in the menus at the top of the screen. At the conclusion of the webinar, an email will be delivered to you within 48 hours. It will include your webinar certificate. In the second half of the presentation, we'll be listening to Mr. Brian Lannon. However, our first presenter for the evening is Mr. Russell Brown. Russell is an educational consultant in Victoria and has over 20 years' experience using Texas Instruments calculators. He is one of Australia's great gurus on anything involving CAS, data logging and Texas Instrument equipment in general. So thanks, and over to you, Russell.
Thanks for that. Hello everyone. I'll just get the desktop showing here. Just before we get started, just a few important things with the students' requirements in the exam. Obviously having a fully charged calculator is a pretty good start. A lot of students seem to struggle with the charging of their calculators because they sometimes plug it into a computer, but if the USB is not live, in other words when the computer is not being used, there is no power going through there. So I would suggest that they use the wall charger that comes with their handheld, or even if schools have the docking stations or the charge bays, the same thing. If you just put the calculators in those for a few hours, 2 or 3 days before the exam, they'll be fully charged ready. Now, if you don't have one of those docking stations, it may well be an opportunity to use the volume purchase program to actually chase some of those up prior to the exam. You'll just need to contact the TI office in Melbourne with regard to that. Just quickly having a look at some of the settings. If you press the Home key on your handheld, and under number 5, Settings, under Status, number 4, you can see that you should be having version 4.0. It'll look a little bit different to this on the handheld because obviously I'm using the emulator here, but 4.0 is the latest. If your students are using 3.9, that's fine. There is one little thing that I'll show you in exam readiness that's only available on 4.0, but there are ways around it. So I would actually suggest 4.0 if you possibly can. You'll notice on the handheld, when you go to it, that the rechargeable battery display will tell you the percentage up there. You make sure the students have got at least 75% going into the exam. So that's just a little bit of prior homework to do. The next important thing, of course, is our mode settings for further maths, particularly an issue if students are doing further maths and maths methods, because there will be some slight differences. We'll be just looking at the further maths today. The display digits is float 6. Now, if you've been using the TI-84 in the past, by default it was around about float 8. Float 6 means it will give a maximum of 6 digits in the display. You can change that on the run just by pressing ANS or even enter will bring the answer, highlight the answer, bring it down to the next line, and it will give the full 10 digits there. So you can actually just check it on the run if you wish. One of the other important things here is to go into degrees, particularly for your trigonometry sections. And the other one that we need to change is the calculation mode. By default, it sits on auto, so we'll need to choose approximate there. In other words, all your answers will come out as decimals. And that's all that is required for the further maths. When you do make some changes, it's very, very important that you go to make default. And that will make the change, not just the document you've got open, but all documents that you're going to be using all the way through the further maths course and the exam. You'll notice on the screen here something that mentions Scratchpad. I would personally encourage the students to avoid using the Scratchpad completely. All your statistics has got to be done, basically all your plotting of statistics has to be done in the document side anyway, so just leave the Scratchpad alone. It does create some issues there in history where you've got to find variables, and if you haven't cleared them, then some of the students get a little bit lost trying to clear the variables there. Whereas in the documents, they start a brand new document, the variables are automatically cleared. So make sure you press Make Default. So we'll go from there and we'll just create a brand new document. I just want to have a look at a few little bits and pieces. I'm going to add a calculator at this stage, and we'll just do a couple of quick little things here. So if I put in, say, something like 2, 3, 4, 5, 6, a very imaginative number, multiply it by 9, and then multiply it by a decimal, for example, so 7.22, and let's divide that by 100. You'll see that you've got a display there of 6 digits because that's what I've got it set on by default. Now, if I actually want to show the full amount, and this is probably only crucial really for things like the business mathematics module where they're asked to answer to the nearest cent, and it's a very, very large number. So for this example here, for example, if they ask to go to the nearest cent and they just wrote that down, then they would end up losing a mark. So you just highlight that, press enter, and you can see that you get a much larger display there. So we don't actually have to change from float to 6. So they can just do that basically on the run. The next little thing we may need to have a look at, probably no big deal for further maths, but if I go to my inserting another page, for example, a graphs page, several ways of doing inserting graph page. A lot of students and teachers, I've noticed, running PDs, they go to the home screen and they go down and choose one of these icons. So that's fine to add another page if you wish. Unfortunately, sometimes some students get to this page accidentally. They press the home key by mistake and they're partway through doing a problem in their document and they think they've lost it all and they start a new document and try and retype everything else in. Now, if they do accidentally go to a screen like this, number 4, current, so if it's not greyed out, you can see the recent is greyed out here. If the current is not greyed out, that means it will take you straight back to where you've been working. So that's a useful thing to let the students know just before they go into the exam, just so they don't panic. So I'm going to insert a new page, and I'm not going to go home. I often tell people that the reason why Bill Gates made so much money is because he never went home. He came up with shortcuts. So what Bill basically had here was, say I want to add a new page here. A shortcut is Control and the letter I. Once again, you could use Control and then the dock key. You'll see plus page at the top. But I'll just use the Bill Gates method, Control and the letter I. And we'll add a graphs page. The reason why I'm showing this is it's not necessarily going to be used by all students, depending on the modules they choose. If you go to your menu now, there's settings down the bottom here, and you'll only have those settings if you've got reasonably current operating systems, like 3.9, 4.0. The display digit is float 3. Now that means it's only going to give you 3 digits on there to try and avoid clutter on the screen. If you want to bump that up, you can. You can, by the way, if you do only have the 3 digits, you can just move your cursor over that value and press the plus key, and it will automatically keep adding digits to it. Or you can go and change it here. If you choose auto, it follows what you set in the general settings. So by default, the general settings were float 6, so that would give it float 6 if you chose auto. The graphing angle here, auto, because we've set it in degree, that's fine. We could actually go and set this in degree as well. But because the general settings are in degree and it says auto, it will follow those. I would still play safe and put that into degree. Geometry angle they won't need to use. And once again, if they make any changes here, they'll need to choose make default. You will have noticed here on the top right hand part of the screen here, it actually says DEG or RAD. In this case, of course, we've got set to DEG. This permanent display is on operating system 4.0. So that's the latest operating system. If it doesn't say that, then you don't have the latest operating system. Now, the advantage that this one has, of course, is if I now just insert Control and the letter I, and I insert a data and statistics page. Of course, it's not showing anything here because I don't have any lists, but if I now go to my menu, it also has a settings now, and only on operating system 4.0, and we have a box here that says diagnostics. If we tick that and go make default, when we do a linear regression, it will automatically give the equation and the R-squared value on it. So that's something new in operating system 4.0. So if you like that feature and not having to go and use the statistics, the long way of getting R and R-squared, then put operating system 4.0 on your and the students' calculators. Now, moving between pages, you notice that we've got a few pages here. You can use your control up arrow, and you can control up arrow takes you to thumbnails, and you can just use your arrow key and just move around to the one you want and press enter, and it will bring you back down to it. You can just use control on the left arrow and it will take you back. Control right arrow will take you forward. And you can just, of course, mouse up to the tab here and choose the one that you want. Now, the next important thing I want to do with navigation here is using new problems. Because the handhelds can only have one document open at any one time, unlike the computer, I think it's a wise and good exam technique to actually create new problems. And that means they can just have the one document going. By having a new problem, then if they've got a list name in problem 1, in problem 2 they can use the same list name, they can use A, they can use X, and the variables don't get tangled up with one another. So it's a very, very nice way of working without having to try and go back and have a look in my documents to see if you've saved it. So if they're part way through a problem and they get up to part 3 out of 5 parts and they get a little bit lost, they can then start a new problem and go on to the next question. They need a little bit of time at the end, they can come back to the problem where they're part way through it, add another page and continue on. So a very, very nice technique here. At the moment, the first digit that you see on these tabs, that tells us it's a problem 1, page 1, problem 1, page 2 and so on. To put a new problem in, and I'll just give you an example here. If I go back to my calculator page and I put in 3 and store that, control var key, store that as the letter A, if I now put in A, that will remember that as being equal to 3. Now, if I now want to use that letter A, and even if I don't know I'm going to use it, I go into the next question and they've got an A in that as well. If I start a new problem just by going to my doc key and insert a problem, so no shortcut like control and the letter I for page. This is a new problem in the same document. And I'll add a calculator now, and you can see up the top it says I'm in problem 2, page 1. And if I put in A now, it doesn't carry it across. So very, very nice for doing separate questions in an exam. Then probably the next important thing that's you're not very, well, it's not commonly used by teachers and students, is what we call Maths Box. So I'm going to start a brand new document now. So I'm just going to go up here. And a Maths Box is a notes page. So you might think I'm going to add a notes page. All of you have used your calculator page. Some have used a graphs page. Probably not too many have used geometry. You will have used list and spreadsheet, and definitely data and statistics for your stats. But if I do add a notes page, if I just type in something like hello, that's just a normal note. But if I now put in a Maths Box, just by pressing menu, and you'll notice that I have different menus here because I'm in a notes page and not a calculator page. If I go to insert, it says insert a Maths Box. This is set on US English. If I had it set on UK English, that would put an S on the end there. You'll see a shortcut is Control M. So if I choose that, you'll see a little red dot around there. So now if I say 3 and I want to store that as an A and go enter, I can now just go and say 5 multiplied by A. So notice the A is bold because it has been assigned or defined or stored. So there it is as 15. And if I go back here and change that to a 7, that will automatically change that and keep it up to date. Now you might wonder what use is that, but you'll find it very, very useful if I just show you an example of it. This one here, one of the things that you're going to have to do with your students is this one here. Quite often it appears on the exam where you're given a standard deviation of X, you're given an R value, you're giving a standard deviation of Y, and then you're asked to find the slope or the B value. So there's a couple of rules here, and those rules are given to you on the exam paper as well. And basically they're asking you to do some substitution. Well, what I've done here on this example, and you'll all get access to these files, I've just gone to a notes page and went Control M, and in here you'll see I've just put the R value. Here's the R value that they've given me. Now you won't know what R value they're going to give you on the exam, so you can just put anything in there. Just make sure it's between -1 and 1, and just store it as R and just press enter and it'll give you the value. It'll just regurgitate what you've got there. Do the same for the standard deviation of X, standard deviation of Y, and I've put in bar X and bar Y, mean of X and mean of Y as well. I haven't put any numbers in here at this stage, so I've just used an underscore. And that was, the underscore on the handheld is just Control and the space key. So I've just left it blank. There's no reason why you couldn't have just put a number in there if you wished. And then it says, do not edit these following lines. So if I go up here and make a change to 0.765 when I go into the exam and I see what the number is, it automatically will do all the calculations down here. So this is using notes page, and both myself and Brian will have a look at using this a little bit more then you'd probably imagine. It is an absolute magic way to go. So what I'll do here is if I just have a look at this one here. So there it is there. So just imagine that in the exam that was 0.82. So I just change it and press enter. The standard deviation of this, let's say it was 1.45, enter. You can see that the slope or the B value is changing automatically down here. So if you watch that bottom one when I change this value, so I'll change this to 3.78. When I press enter, you'll see the slope changing. Now if I had the mean here, I could just put in the mean of say 2.3, enter, put in the mean of Y, 3.4, enter, and down here I have got the equation set up. This is just using the rule that they've got, and it will give me the A value, and there's the B value in the A plus BX rule. So you can see that you can set a lot of these things up very, very early in the piece. And what I've done here, I've just done a few more of that. So when you get this file, you can just have a look at it. So they're going to give you the regression equation or the slope and then ask you to find the R value. So once again, you can just set this up like this, and students can just come in and put in their values. Notice that I have changed from problem 1 here to problem 2. And by doing this, I am making sure, so now I'm going into problem 3, because remember, this B will be a different value to the B that I've used elsewhere. So this is using the problem, the new problems, and also using a notes page. I just want to go now onto residual plots. So if I go back to this one here, so this example here, of course, is just using problem 2 and problem 3 in the document that I'll supply for all of you to use. Now this one here is an interesting one here. For some reason or other, students have some trouble answering this sort of question on the exam. So what's happening here is the students are given a line of best fit. And then they're asked in the multiple choice question, so they're given a variety of residual plots, and they've got to try and pick the right one. So what I suggest in readiness for the exam is that you actually get the students to do a few of these. And also you'll notice the R squared showing here. This is what I was telling you about earlier. That by ticking that diagnostic box on operating system 4.0, it will give you the R squared when you do a regression equation. You'll also notice that this equation is of the form y equals A plus B multiplied by X. This is the form that you'll see on the exam. If you use the MX plus B form, you'll still get the same answer. But if you're wanting to match what's going to be on the exam so the students don't get lost, then A plus BX is the one to use. That's the one that will be showing in the exam questions. The only thing you need to be careful of here is because this is A plus BX, this may say A, in other words, a value, plus negative something, because we're always adding parts on, so we may be adding a negative to it. So it won't have a subtract sign there, it will be plus the negative. So just remind the students to look very, very carefully on the A plus BX version. I just want to have a quick look at this one here so you can see what's happening, just in case you haven't done these before. So here's the residuals. Here. Just go back to the start here. So there's a question here, and here we've got height versus belly button height. This is data from the Bureau of Statistics. I'm going to do a regression analysis now, so I'll just do it via handheld. So I'll go to Analyze, choose Regression, and this is where I was saying you've got the two choices. Further Maths and General Maths, the emphasis will be on showing it in the form A plus BX. But as I said, if you feel more comfortable working with MX plus B, then so be it. So there's our equation. There, our line of best fit. And if I want to show residuals now, a lot of teachers are using old skills from their previous calculators where they've gone over here and changed this to residuals. There is no need to do that, because if we go back to menu now and go to Analyze, we can choose Residuals and Show Residual Plot. And the advantage of this is it keeps the scale the same at the bottom. Now, what you need to emphasise to students for exam readiness is that basically all we're taking is this line of best fit, and that is becoming horizontal and becoming the residual 0 line, this one here. So I'm pointing to the horizontal line. And basically, if you just grab that line and drag it down, the pattern will remain the same all the way along. All they're doing is dragging this down to be level with that, and of course, the spacings are exaggerated a bit because of the difference in scale. So You get the students to try a few of those. On this example here, I do have a couple there that they can practice and see what's happening. So that's quite a nice little one to have a look at. So that's, and the other very, very important thing here is when responding to a question on the coefficient of determination, in other words, your R values and your R squared values, don't give general definitions that you're going to quote from a textbook. You must use the example, in other words, the variables that are in the example in the actual question. So don't just use something that's just a general quote. So here's one of the questions. The coefficient of determination of the above example was 0.67. What does this value tell us? So here's the sort of answer that we'd be probably trying to look for. So the coefficient of determination tells us that 67% of the variation in the score, the dependent or response variable. Now I'm starting to introduce response variable here as the dependent because next year they'll have to be aware of the response variables and the explanatory, but not for this year. So you get the students used to answering in terms of the actual practical situation in the question. The next thing I want to have a look at here is just working from some data lists. Now, the only thing I've really ever seen on the exam, and just as a point of interest, I'm not an examiner with the VCAA, and I have no relationship at all with VCAA, so I'm just giving you this information on my prior knowledge of the students and working with a lot of teachers. The only example where I've actually seen where students have to use lists is in something with just a single list of up to about 12 data values. So in this case, they've asked for the average or the mean. So students are probably more used to putting it in here rather than creating a list in the calculator page. So just put them in here and they can just, once they've got them in there, they can just go to a calculator page and put in the mean of IQ. So IQ, of course, I've just named that up here. So I think probably the majority of students and teachers alike will probably go straight and use a full statistical analysis, you know, one variable analysis there and get the whole generation. So just go to, in a calculator page or even in a spreadsheet, just go to statistics, stat calculations, one variable stats, and that will give them the whole, well, the whole analysis. But we also do have an opportunity where you can just put in these single ones. It is just obtained under your stat menu, and you can play around with and find out where they are there, or just type them in. The important thing to remind your students too is that in Victoria we use the sample standard deviation, SX, not sigma X. We don't use the population one. So emphasise that. And as I said, the majority will probably go for this stat, the full stat results. So just very, very quickly on that one there, if we just open up this one here, if I just put in a brand new thing and just put in some lists and just just call that WET just for any sort of thing. And if I just put in some values here, and you can do it on this page. I actually prefer to do it on a calculator page. There is a good advantage of doing it here because if you do find you've made a mistake, that will upgrade live if you do it in here. So we'll probably just do it in here just to show you how you can do it in there. So menu, statistics, stat calculations, one variable statistics. Number of lists will always be one. So if students look at this and they think, oh gosh, I'm doing something here and I've got two lists, it will always be one list. This one here, that says column A. Most students will probably want to name them anyway. So just press the arrow key and you'll choose that one. And the answers will go in column B. Just OK. And there's your answers. Now, we've got two standard deviations or two standard deviations. One's a sample one, so SX is the one that we use, not sigma X. So that would just give you those values there if you wish to do it that way. If we just go back here, I am mindful of the time. We need to get through a fair bit here. This next one here is a very similar sort of question that appeared on the exam. You were given a box plot, a little bit different in orientation to what they're used to. And they're asking some questions, but the questions are generic. So basically, they're looking at, if they give these box plots here, they're actually checking to see if students know there's approximately 25%. It's not going to be always exactly 25. We may have the same number appearing in two compartments there, even though we've tried to divide them into equal 25s there. So you'll see in the exam, in the multiple choice questions, they'll say is closest to. So in this case here, we've got 12 out of the 50 here of the students were greater than 22, I think. So the value 20, sorry, are greater than 25. So 24%, not 25%. So it's going to be roughly around about the 25% based on each quarter. So once again, emphasise that to the students. I think they are fully aware of it. So here's an example, once again, very, very similar to this one here. So this is similar to a question that's on the exam. So the percentage of females with a right foot length greater than 25 centimetres is closest to. So there's the female box plot, greater than 25 centimetres, so that's Q3. So we're looking up here. So we're looking at roughly the 25% answer there. So you can practice these very, very easily with your students. Not hard to actually set them up like this, or you can just have them as you would normally just have them on top of one another. In other words, running horizontally. So if we do look at something like this one here, if we just go back, I'll just go back here. So if I just go back in here, so if I just insert a graphs page, inserting a data statistics page, and I have a lot of things sitting in here. So if I just choose height, for example, so that's univariate, I can do a box plot out of that. Now, hopefully all of you are aware that we don't actually have to go back to the menu. If you use a right mouse click, which on the handheld is Control and the menu key, that will give you, wherever your cursor is, just a reduced number of menu options. So I'm going to go out here and right mouse click, Control menu, and I can do a box plot out here. I could put the height over here, so if I choose height to go over there, I've now got it running that way. If I go down here and say I want to split on gender, so that is basically how how we're doing those examples, and quite often they appear that way on the exam, just to make it a little bit difficult for the students to relate exactly what they may have written on their sheets. So, but the interpretation is still going to be the same. The next one I want to have a look at is our histograms, and I'll just go back to this one here. So quite often we've given a histogram, and as I said, you are never ever going to have to create histograms on an exam. You just cannot put that amount of data in. They're not testing to see whether you can type data in. They're asking you to interpret. So what they may do is they may give you then a series of box plots and say which one matches that. So how do you practice doing that? Well, what we can do is we can actually split the screen here. And what I'd suggest you do with splitting the screen, where it says doc, it says page layout. So anything to do with the document, you want to do some changes to the document, select the layout, and it gives you images we want to use layout 3. So two horizontal panes. And down here, we're going to put in another data and statistics page, and in here, I'm going to put in the box plot version. So there's height, and I'm going to change this to a box plot. And by the way, just before I change, this is called a dot plot. Very commonly used, the term in the exam, and particularly again for next year. They are actually a better representation than box plots or histograms because they are the actual data values. Here, this is data values trapped within bin widths, and a box plot, of course, is in 25% modules. So this one here, I'm going to right mouse click here, or I could have gone to menu, plot type, and changed it. But as I said, if you want to get used to this, I'm going to go in here, right mouse click, and choose box plot. So there's the matching box plot to that. So you work with the students and try and see if they can see why that would be the one they'd have to choose. So practice a few of them. On this document, I do have a few of these there. Now you will notice that these scales are out a little bit. So if you go down here, and you can actually just change the scales. Move your cursor so you've got that vertical blue line with the arrows, and that will allow you to match the scales with those at the top. So once you've got them matched, you can see now how they compare. So once again, you just need to make sure the scales are in the right spot. So just move your cursor. On the axis, you'll get a vertical line with two arrows pulling apart, and just grab, so on the handheld, just control click or hold the center click button down for 2 seconds and let go, and it should have grabbed, and just rub your finger gently on the mouse pad and just drag it to line up with that above. So in this example here, I do have some more that they can choose and practice, or you could just go and give them any histogram and ask them to make a box plot and find the equivalent to it. So Brian, I think I'll change over to you now, and you can have a look at the next section, and if time permits, I'll come back and do some more of the stats.
Ready to roll, mate. Russell, there was just a couple of questions in the chat window there asking about the when you're assigning the variables, where you got the subscripts from.
Okay.
Now I know hiding in the
Do you want me to? All right. Okay. So the subscripts here. If I just insert a new document here, just so we've got a brand new one, and say, for example, I want, now in further maths, most teachers are used to using control, in other words, the store key, and putting it as A. But say I want to call that A.
I think, Russell, your screen's been moved on. I'm not sure there. Sorry, we're just checking here. I think we're in transition between you and Brian.
Oh, okay. All right, Brian, if you... No, it's back on me. I'll have to go back to sharing my desktop again. Okay, yeah, they've been taken off. All right, so we're using this store. For maths methods, I would use the assign key or define. Now, if I want to call that A1, I can just put a 1 there and then make that into a subscript. But if you go to the two-dimensional templates, which I'm pointing to now, so it's just to the right-hand side of the 9, or if you're used to doing shortcuts, control, menu, and you can get math templates from there. But right down here, the last one is a subscript. So you put that in, put in a 1, and enter, and there it is there. So that's nice for Y2 and Y1 and SX and SY. And rather than have to go through it again, say, for example, I want to add 3 to that, I don't need to go through and try and make that A1 again. Because that's been stored, I can just press my VAR key, the variables key, and there it is there already with the subscript on it. So once you've done it once in a problem, then you don't have to do it again. Okay, thanks for that, Brian.
All right, mate. Yeah, I found some of them in the catalogue, but I couldn't find all of them. But yes, certainly that template subscript will work for any of it, which is good.
It will.
Yeah. is good. What do you think of all this, Julian?
Very good. Thank you, Russell. That was very informative. A lot of good note stuff there. I better quickly introduce Brian before we move on to him. Brian is a teacher at Victory Lutheran College in Victoria. Brian has been teaching for a long time, isn't that right, Brian? Over 28 years, I think, in Victoria, New South Wales and New York.
I think Russell's been longer, though.
Or possibly, but yeah, I've known you longer. I've known Brian since the 90s when I was back in New South Wales. He's always very informative and very entertaining, so I'll pass it over to you, Brian.
Fantastic. Thanks, Julian, and thanks, Russell. And happy participants online. Good evening. I'm going to have to blaze through this fairly quickly. Russell certainly is the guru, and I do remember going to conference sessions of Russell's, and guess what, mate? It was more than 20 years ago. You had 20 in a little note before. It was more than 20 years ago, I remember that. The first was the latest of technology. Participants, what you haven't seen as much of behind the scenes here, Russell has prepared a wonderful document here. And the great news is you will be getting a copy of it. More than that, 15-page document with all these wonderful tips. See the little calculator icon? Russell has hyperlinked all these wonderful TI files to the document, and you get a copy of all of those as well. And so, as I said, I'm going to scoot through this fairly quickly. I really appreciate the stuff that Russell's done in the preparation for this. I've taught further maths quite a lot, and I think that this course, more than any other, really highlights the value of the Nspire software and handheld, and it's a great one to get the students into. And of that, the number one topic I think is data analysis. I really like what Russell's done here with these little notes page. Shall we say, formula wizards? Is that the right term? Such a clever idea. This one, as you can see, it does the 2-point formula. You know, x1 equals whatever, y1 equals whatever, x2 and y2. Here's our formula. It will calculate automatically the gradient and also the equation of the line. Now, come back to the document that Russell had initially. Here's an exam-style question on transformations. Okay, so we've got time in the first row, distance in the second. The exam question is saying we've applied an x-squared transformation, and look, what's the line going to look like? And here are our options. Exam-style question. Only the numbers have been changed slightly to protect the innocent, which is us. Now, looking at this, sure, we could crunch all the data, we could put all the data into lists, we could do the transformations, we can get the graphs, we can do the regressions, all very good. And you should do that with your students. But the nature of this particular webinar is exam readiness. Guys, it's already September. We've got to move quickly. Your students are under time pressure in the exam. Pick 2 points. Come on. Look at the options here. The independent term, negative 30, negative 2.3, 21 at 6.9, 1.5. They're nothing like each other. And so also are the gradient values. Here's the trick that this little wizard can do. Let's take the point 111 and the point 2582. Now, in the text here, you see that written in the reverse, but 111 and 2582. Here we go. If I put in, I edit the blue. Actually, I'll do it the other way just to show you how I can edit this. I'm going to put the 25 in here, okay, and press Enter. And then the 82 here. none of those options are exactly 3x plus 8, but I tell you what, there's 4 of them that are nothing like it, and this is the closest. Bang. I'm selecting B, move on. You know you've only got 90 seconds on average per question. And that's a lovely one. You know, kids will love that. Here's another transformation one. We're told in the question, what does it say here, Russell, exam style question, but only 35% of candidates got this correct. That 30, I'll look this one up, Russell. That 35 was the modal score, but nevertheless 35 isn't great. You'd hope that more students would get this. Okay, I've got X against Y. The question is asking us what would be the gradient of the doing of the line of best fit after a reciprocal transformation. Hit on this, bang, that goes into our, hang on, that one I've got open here. It goes into our question here. There's the X values, there's the Y values, there's the reciprocal transformation, and that's what it looks like here. You can run it all through, you can do all the line of best fit, but hey, why spend all the time typing in the data? You haven't got time for that. Do the 2 points. Just take the point 1, 250, and let's say the point 635. Go back to this other thing we had, like 2 points. That's all we need for a line. Go back to this guy. What did I say? 1, but I want the reciprocal of 1, don't I? Guess what, guys? That's a good one to work with, reciprocal of 1. I can do that one in my head. And what does that tally to? It was I'm going to have to go back to my notes here.
It was 250.
250, thank you.
Yeah.
So the 1 to 250. And hit that. And then what would I want to do? I want the reciprocal of 6. Guess what? I'm lazy. 1 divided by 6. Why not? This thing's a calculator. And
35.
And 35, as you can see. So the Y coordinate, 35. Bang. And I've got a gradient of 258. You saw on the other thing that it's exactly 250, well, closer to 255 than 258. In the exam question, you know, 250 is the only one in the ballpark. Bang, there's our 90 seconds, move on. Got the idea? As I said, I don't have time to do all of these, but here's a note on logs, and Russell has typed in, if you, okay, I can work out the reciprocal of 2 easily enough, so it's got to be one of these options. But as for the log of 5, now there are 2 logs on your calculator. The point that Russell has made here, make sure that you use the base 10 logarithm. On your calculator, if you, let's just whack in a page for that. And Russell, I don't do the Bill Gates shortcuts as much as you do. I go through the menus, but you know, it caters for the different people among us. If I don't put in a base for the log, it will automatically accept it as 10. Okay, and bang, job's done. So it wrote the 10 in. Don't go for natural log. Some of your maths method students might think that that's the way to go, but no natural logs here. As Russell indicated before, if you've got the diagnostics switched on, when you do a statistical regression, it will come up with the R squared now, as well as the model, so in this case the linear model. The beautiful thing here is, once you've done a regression, any regression, the calculator stores, it invents a whole lot of variable names, including one that's called stat results. So here's a nice little trick. Here's some data. This is, I think, sucked down from the Australian Bureau of Statistics, what is it called, Survey of Schools.
Census of Schools.
Census of Schools, that's the one. Let's just change the view of this so that you see it as students will see it. And here we have a graph of the height against the belly button. And guess what, people? The taller people are, the higher their belly button tends to be from the ground, generally. And if you've done a statistical regression, a linear regression has been done here, as you can see. You see the line. But hey, where's the equation? If you've forgotten that, just click on it. Bang, there it is. And here is our R-squared value. Now, if you want to see the full set of summary stats, let's just go with a calculator page here. Among the variables, because a statistical regression has been done, and there's all our things, you know, arm span and, you know, belly button height, eye colour and so forth, that results. There it is. Bang. And enter. There they all are. How sweet is that? So you've got that on your calculator page. There's our R-squared value, but of course you also saw it on our data and stats page. Good fun stuff. Now, Russell before he used data like this to show you a box plot. Here's an exam style question, a set of data, and it's saying is a particular value an outlier or not. Okay, we can crunch the data, we can calculate the 5-figure summary, we can look at the quartiles, we can calculate the fences, we can go 1.5 times the IQR, and all this good fun stuff. Guys, why not just quickly construct a box plot? There's the outlier. It is an outlier, we can see it. And, you know, the other beautiful thing is, with your calculator, when you've got, so there's a set of scores there they are, you will get a copy of this file. There's the box plot. Now, your students do not have to clear their calculators when they go into the exam. So give them this file and just say, hey guys, if you get a question like that, who cares if it's marks or scores or, you know, height or whatever, just change the data and then hit the graph. The graph will update them automatically. Okay? You're going to see the deal. You may have to change the window settings a bit, but you know, they don't have to clear. They can use these templates. They don't have to clear them. Guys, I'm conscious of time. We're going on to time series and smoothing. What we have here is a picture of the was it the Shanghai Stock Exchange Index? No, it's not. It's births per particular month, and we're looking at the smoothing. What have we got? 3-point moving median. As I just said, you don't have to clear your calculator. Give your students this file. You know, it may be that the month and the Shanghai Stock Exchange Index, whatever. They just change the data. Look at the formulas here. This is how it's done. So there's your 3-point moving mean. In this file, we've also got the moving median. Look how it's done.
Now, Brian, with the mean there, they could have just used the MEAN B1 to B3 as well.
Exactly. Yep.
But I've just added them up and divided by 3 because I think students are probably more comfortable with that.
Yep. Yeah, actually, Russell, in another one of your documents, you did use mean, and I think both. I think it's nice to show the students both. The greater transparency, the better. Participants, look, these files are wonderful for illustrating and teaching the concepts to students. Please don't think we're saying skip over the real teaching, but hey, it's September. You know, at this stage, you know, this sort of stuff you hopefully have already done. Arm your students with these files. You want to give them tools so that you send them into the exams and say, righto guys, here's something that's workable. You know, crunch in the numbers that you're given in the exam. There's your file. That's going to help you. Next up in our deal, we've got calculations of seasonal index. Same deal. Can you see here? This is just another one of those templates. Now, sure, I know it's an open book exam. The students will have that that formula in their notes. Sometimes I'll have to transpose it, I know. But look what's happened here. We've just got the mean of sales, so we've just got a whole heap of sales figures. Where are we? And there's more goodies in here than... so here's our month and our sales. We've got moving mean, we've got moving median, all sorts of wonderful things. But of course, as soon as those data are entered, they're there. And so the variable name sales exists in this document, in this problem. So we only, in order to calculate the mean of sales, type the letters MEAN, open the brackets, hit your variable key, VAR, you're going to find that sales is one of the variables. Okay? I'm scooting through this. Russell, this is a fantastic document. I'm not going to have time to do the matrices, but could I just point out that matrices, I think this is the topic that I start with in both Year 11 and Year 12, because I think it, more than anything, really gets students in. It's a new topic for them, something that at Year 11 they mostly haven't seen before. And the fact that you can just bring up a template key, type in a matrix, and then, say, raise it to the power -1 to find its inverse, or something as simple as put it into the solver if you're solving, in this case, a pair of simultaneous equations. This matrix times RH, I think the R stands for roosters and H for hens. So I've got, one rooster and 5 hens cost me $34, 2 roosters and 9 hens cost me $63. How many roosters, how many hens? You know the type of problem. Bang, hit the solve, there's your result. Have your students read the question, though, and see what they're asked for. Sometimes they're not asked for the actual solution to the simultaneous equations, but they're asked for what's the inverse matrix, for example. These are quick activities that I'm hoping that you would be doing with your students as you teach this topic. Russell,
I think Brian, it's great that people will have access to those, so they'll be able to work through it themselves, particularly the activities you haven't got to.
They've come along to a great webinar here.
Fantastic.
Can I just plug an ad, though, mate?
Yep.
We've rushed through this. You've got 15 pages of wonderful stuff here that Russell has prepared. Russell and I are running another one on the 24th of September. And I think it goes for longer. I think it goes for 2 hours, not 1. And it's not an exam readiness one, but it's looking at particularly the changes to the Further Maths course as of 2016. So we'll be reviewing some of the main stuff, but also focusing on what's new and how we need to prepare for that.
Fantastic, Brian. And I've just been informed that the webinar will be up on Monday, so for people who would like to look through the rest of the document, they'll have the opportunity to have a look then. So, look, thank you. Obviously, we're running out of time here, so thank you very much to Russell and Brian. I hope everyone got plenty out of that presentation. I know I've learnt quite a few new things. Just bringing up the last bit here, sorry. Now, your feedback is obviously important as part of the process to providing you people what you'd like as educators. Obviously, it's very important that we get feedback in terms of what you thought of tonight's webinar. So please take the time to complete the survey at the conclusion of the event. So it will come through to you once the webinar has been completed. So again, it's very, very important that you do give us some feedback about what you thought of tonight's event, and again, obviously some great information there. Just a couple of things that have come through from the chat, and there were some very, very good questions and answers coming through. One of the questions was, how can we get version 4.0 for our calculators? On the education.ti.com website, as you can see hopefully on my screen, there's a link here to the TI-Nspire update, so you can actually download that and install it onto your computer or onto your calculators. The other thing that we also have is the webinars link, so we can actually go into webinars, and you'll have to mind my very slow computer as I'm over in Western Australia, so everything's a little bit slower over here. Okay, so we've got the webinar link. Now, the great thing about the webinar link is there's a few little bits of information that we've got here. There's obviously the upcoming events that Brian just mentioned. You'll see Russell and Brian coming up in the future. We've got tonight's. You'll also see myself and Jodie Carruthers. There's a whole heap of information there in terms of upcoming webinars. So plenty of topics, plenty of information. The other thing that we also have here is an on-demand link. So if you go on demand, and what you'll find, as I mentioned, on Monday, or around about Monday, you'll have tonight's webinar. We also have many of the previous webinars that have been recorded. And in this part of the link, you'll notice that it has the date, the information. You can play the webinar, and you can either play it as a live event or from the recording, or you can actually download it and watch it in future as an offline download. The other option we have here is also download associated documents, and all the TNS files, all the documentation that's been on tonight and previous webinars is available there. So I hope that actually answers some of the questions that came through. Again, thank you for listening and viewing tonight's webinar. I hope you can join us for the future webinars. I'd also like to take this opportunity one more time to thank Russell and Brian for a fantastic and very informative information night. And it's good evening to everybody. Thank you very much.
Good evening all.
Terrific. Thank you.
Thank you.
All the best.